So continuing with the discussion of rational functions, let's just quickly recap with what we did in the previous videos. That is, say we have a rational function like this, we'll try to factor both the numerator and the denominator. Now the numerator is already in the lowest form, so what we would do is we'll factor the denominator to the lowest possible form, and here -2, the factors are -2 and 1 that add up to -1 in the middle. So these are the factors. So what you notice is this, that x minus 2 and x plus 1, they are factors of the denominator, and neither of them is a factor of the numerator. So the vertical asymptotes, okay, will be given by, asymptotes would be given by x plus 2 equals 0 or x equals 2. Okay. All right. Now we don't need this large. Okay. Or x equals 2. All right. And the other one would be x plus 1 equals 0 or x equals -1. So these are the vertical asymptotes. And for the horizontal asymptotes, what we have is horizontal asymptotes. We have that the degree of the numerator is less than that of the denominator. So for the actually here just horizontal asymptote, so we have y equals 0 as a horizontal asymptote here. And if you graph the function, okay, you can use your graphing calculator. I'm just quickly going to show you a graph here. Okay, let me just and so here you see that we have vertical asymptotes at x equals 2 and x equals -1. And if you look at the larger values of x, that is, we go ahead and do this here. Let's just go from -100 to 100. All right. And then we can see that, you know, as x approaches those large values, y is approaching to 0. Okay, so y equals 0 is a horizontal asymptote here. Now again, if we have a rational function like the one here, if we factor the numerator and the denominator, what we get is that, first see I'm factoring a 2 out, and here in this case -3 times 2 is -6, and they add up to what? They add up to -1, so they will be factors. And here x minus 4 will factor as x minus 2 times x plus 2, right? So what we notice here is this, that is x minus 3 is a factor of the denominator but not of the numerator. So x equals 3 will be a vertical asymptote, right? Okay, and then x plus 2 is a factor of both, so that won't happen. And then the degree of the numerator is the same as that of the denominator. And if we take the ratio of the leading terms, that will be 2 over 1. So y equals 1 is going to be a horizontal asymptote, right? Okay, so and of course at x equals -2, we have to make a hole at that point, right? Okay, so let's look at a graph of this function to see this thing. Okay, so I'm just graphing it right here. Okay, and then, well, let's just give it a little bit more window to sketch. All right, so here we go, and we have a vertical asymptote at x equals how much? At x equals 3. All right, And then for x equals -2, what we will have is, so at -2, we will have, we just have to, insert that whole by hand, because at -2 denominator is 0, but the numerator is not. So when x is -2, this will be -4 over -5. So the whole thing would be 1.6. All right, this is a point. So we'll just make a hole at this place. All right, or let's just, yeah, okay. Yeah, that's a hole here. Okay, and then the horizontal asymptote is, as I said, y equals 2, because both the numerator and denominator have the same degree. All right, and here I don't know why I wrote y equals 1. 2 over 1 is a 2, so I apologize. Just trying to rush things, right? Okay, so y equals 2 is a horizontal asymptote, okay, and we can just see a vertical asymptote by a sketch also, right? And I'm just using this particular package to do that. Okay, so I'll just write that in a language that it understands. Okay, sorry. Okay, so here, and this is a vertical asymptote. All right, now let's take up another scenario. Now here is a rational function that we did not encounter in our series of discussion, because here the degree of the numerator is greater than the degree of the denominator, right? Okay, again, sorry about abbreviating everything here. So degree of the numerator is greater than the degree of the denominator. So what we will do first here is this, that we shall carry out long division or synthetic division, and notice that the quotient when we divide, the quotient is -1 and the remainder is -7. So if we write it in the quotient remainder form, the form is like this, right? So now what will happen here? First of all, you see this here, that x minus 2 is a factor of the denominator and not a factor of the numerator. So what we have is that x equals 2 is going to create a vertical asymptote for us. All right. Now here, for x going to infinity or -infinity, for the either sides, this will be very small and this will go to 0. So what happens? Eventually the function will act like this straight line. So let's make a graph and see that feature here. Okay, that is, we have this as our, let me just bring it in our window right here. Okay, and just enlarge the, okay, so this is our graph, and we have a vertical asymptote at x equals 2. All right, now say we went ahead and graphed the straight line y equals x minus 1 in the same window. Notice what happens, that eventually the two graphs go together. So this is behaving asymptotic. These two have asymptotic relationship. So in this case, this straight line asymptote would be called what? A slant asymptote of this rational function. So it had a vertical asymptote at x equals 2, and then the line given by the equation y equals x minus 1 is a slant asymptote. Okay, all right. Now going further, so as I said, going further, you saw that this graph of this function here, okay, eventually behaves like the graph of this straight line. Eventually means for very large and for very small values of x. So in case we have a rational function like, say, given by this equation, then notice this. First, let's factor the denominator. Okay, sorry about that. Okay, so denominator factors as x minus 3 times x plus 3. All right, and notice this, neither of these can be factor of the numerator because none of them is a factor of 2. All right, or neither plus 3 nor negative 3 makes the numerator equal to 0. So what we have here is that our vertical asymptotes would again be x equals negative 3 and x equals 3. I said again, I mean they will be this. And here what we would do is that we will carry long division. All right, so when we carry long division, what happens is that the quotient will be x cubed plus 10x and the remainder would be 90x minus 2. I did not show you the long division. You can carry it out and let me know if you have difficulty. All right, so in this case, let's graph the function, and what we will expect is this. Let's just write down what we shall expect. All right, and our function is given by this equation, and what we shall expect is that, of course, we should have vertical asymptotes at x equals negative 3, and or we have vertical asymptotes x equals negative 3 and x equals 3, and eventually the function will behave like this cubic. All right, so what we meant is that, let me first bring this window in here. All right, so we have a vertical asymptote x equals 3, x equals negative 3, and let's just put the graph of x cubed plus 10x in here, the cubic, and you know the graph of the rational function approaches the graph of the cubic, you know, as the values become larger. Okay, let's make them as large as, let's say, negative 20 to 20. In this particular window, they seem to be going together. All right.